Hi, my name is Jason Harlow. Welcome to my V office hour. I'm going to go over the solution to Physics 132 F, Fall 2010, Test 1, and it's problem 5 from version 1. This is based on Night 2nd edition chapter 23, the ray optics chapter. In particular, it's about section 23.2, reflection, the law of reflection. So let's carefully read through the problem. A dressing mirror is mounted on a vertical wall that is 1.7 meters tall. The bottom is 0.3 meters above the floor. A bare light bulb hangs on the ceiling a horizontal distance of 1.0 meters away from the wall with the mirror. The light bulb is 3.0 meters above the floor. How long is the streak of reflected light across the floor as measured perpendicularly away from the wall with the mirror? And 5 different numerical choices of meters there. Okay, so you have to try to picture this. We're going to draw a picture in a second, but the idea is that there's a light bulb on the ceiling, there's a mirror on the wall, and the light hits the mirror and reflects down onto the floor. And since the mirror is kind of long, you'll get this long streak of light reflected. And basically you're using the law of reflection, which is that the angle of incidence equals the angle of reflection. And you start with the top of the mirror down to the bottom, and that'll give you this long streak. So that's the gist of it. Let's look at my solution, in which I've drawn a diagram with all of these distances labeled. Okay, so going back to reading the question, the dressing mirror is mounted on a vertical wall. The mirror is 1.7 meters tall, so I'll label that. The bottom is 0.3 meters above the floor, which means the top of the mirror is 2 meters above the floor. So those distances are labeled. A bare light bulb hangs on the ceiling a horizontal distance of 1 meter away from the wall. So I've drawn the light bulb hanging from the ceiling and a distance of 1 meter between it and the wall. The light bulb is 3 meters above the floor, so that's been labeled, and also it's 1 meter above the top of the mirror from 3 minus 2. And then I've drawn the streak of light on the floor. So the ray of light that goes from the bulb to the top of the mirror is ray 1, and then ray 2 goes from the top of the mirror down to the floor, following the law of reflection there. And then the ray of light that goes from the light bulb to the bottom of the mirror is labeled 3, and the ray of light that goes from the bottom of the mirror to the floor is labeled 4. And so x2 will be the distance of ray 2 from the mirror, and x4 will be the distance of ray 4 from the mirror. Moving down in the solutions, let's just look at the triangles for beam 1 and beam 2. Beam 1 descends a distance of 1 meter and goes to the right a distance of 1 meter. So you can solve for the angle theta sub 1, 2. Beam 2 goes back out a distance x2, which we don't know, but goes down a distance 2 meters. And that's also going to be angle theta 1, 2. So the law of reflection says those two angles are the same, and these are both right triangles, so these are similar triangles, meaning that the ratio of the two sides, 1 over 1 for beam 1 is equal to x2 over 2 for the beam 2. Solving that for x2, you get x2 is 2 meters. Now following a very similar procedure for beam 3 and beam 4. Beam 3 drops a distance of 1 meter plus the length of the mirror, so 2.7 meters down, and goes horizontally 1.0 meters. And there's that angle theta sub 3, 4, inverse tangent of 2.7 over 1.0. Beam 4 is the tiny little beam from the bottom of the mirror to the floor. It goes to the left, x sub 4, the distance we don't know, and it goes down just 0.3 meters, the distance of the bottom of the mirror, from the bottom of the mirror to the floor. Again, theta sub 3,4 is the same in both triangles because of the law of reflection. So these are similar triangles. 1.0 over 2.7 from the first triangle equals x sub 4 divided by 0.3 from the second. Solving for x sub 4, and you get 0.11 meters. So at that point, you just subtract the two distances you got, the 2 meters minus the 0.11 meters, and you get 1.89 meters. And if you look at the answer, the closest one is 1.9. So to two significant digits, it's C, 1.9 meters. So this was a simple application of the law of reflection. Angle of incidence equals angle of reflection. Basically, the hard part was drawing the diagram and reading through all of these distances in the question. So, my name is Jason Harlow, and I approve this message.